Hello all, myself Pandurangachari from EEE department, St. Peter's Engineering College. Today we are going to discuss about transient response of DC circuits. So before going into the topic, we have to know that what is a transient. Transient means a disturbance or surges occurs in a electrical circuits. So because of the transient, how the voltages, currents and how the elements response, that is called a transient response of DC circuits. For example, if you have a circuit consisting of a resistor, a capacitor, applying with a voltage source. For example, the switch is closed suddenly, then voltage is applied to that circuit suddenly. That causes some changes in the inductor and also in the capacitor. How the elements are responding to that sudden surges of voltages or currents, that we are now going to discuss in this topic. Okay, so transient means a sudden surge applicable into the circuit. Surge caused into the circuit. And what is the transient response? Transient response means the components which are having in the electrical circuit responses to that transient is called transient response. That may be cause change in voltage and also change in current. The change in voltage maybe occurs in capacitor. The change in current will be in inductor. Okay. So what is the transient time? The time taken for the circuit changing from one state to another state. We can simply explain this topic easily. For example, in a water, if we throw a stone, the stone we can call it as a transient or disturbance or a surge. Because of that stone, water will splash. Okay, that splash we will call it as a transient response. And to settle down the water, it will take some time. That means from transient state to get a steady state, it will take a time. That is called a transient state. Or else we can also explain with some other example. For example, we are going in a bus. The driver hits the brake suddenly. That causes few of members to fall down, some members to move forward. Okay, so that is called a disturbance in the network. Yes or no? So like that we can explain easily. Transient means which causes disturbance in the circuit, that is like a surge or a transient. And transient response means because of the transient, how the voltages and how the currents will be changes. And transient time means to settle down from transient state to steady state, that is called transient time. Okay. To analyze the transient response of circuit, we have to write a equation. Okay, that equation will be linear integral differential equation. Linear differential equation. Okay, this equation consists of two parts. Okay, one is IC and one is IP. IC means complementary function, and IP means particular integral. Okay, IC means complementary function and IP means particular integral. Okay, so to write the complementary function, we have to make a zero or no excitation. That means if any voltage source is there or if any current source is there, we have to make these parameters to 0 to write the complementary function. And this particular integral will be called as a steady state response, and this complementary function also called as a transient response or transient function. Okay, so to write a transient response equation, we have to make it two parts. One is transient function and another is steady state function. This is called as complementary function. This is called as a particular integral. To write those things, we have to find out initial condition of each component. Initial condition. Okay, initial condition means if we switched on the switch are opened, that is at t equal 0 we are considering it as, and initial condition means t equal to 0 minus, t equal to 0 minus, and also t equal to 0 plus. So initial condition we will consider as t equals 0 and t equals 0 minus, t equal to 0 plus. So t equals 0 minus means just before switching it on. T equals 0 plus means just after switching it on. So there are conditions we have to consider three timeline, but these three timelines are considered as initial conditions only. Okay, for different elements we have to consider initial conditions. For example, if we consider resistor, that resistor is connected to a voltage circuit with help of one switch. Okay, this resistor, this will be voltage and this will be switch. At t equal to 0 minus, switch is open circuit only. At t equal to 0, switch is closed. Switch is closed at t equal 0, and t equal to 0 plus also switch is in closed condition. Okay, so whatever the timeline is there, the resistors will flow through the resistor, some current will flow through, that is I. That is according to the Ohm's law. Okay, before that current will be 0, after that current will be having some magnitude, depends on the applied voltage and it depends on the resistive value. So V equal to I R. So in the same way, if we consider the initial condition of an inductor, okay, one voltage source is applied, voltage source is applied to the inductor, okay, at t is equal to 0 minus, the circuit is open circuited and there is no current through the inductor L. When the switch is suddenly closed, as the inductor opposes sudden change in current, then also at t is equal to 0 and t is equal to 0 plus, the inductor will act as a open circuit. Why? Because it acts as open circuit? Because the inductor will opposes sudden change in current. The inductor will act as a open circuit during the initial conditions. That means during the switching on process of a circuit. Okay. That means at t equals 0, we will consider the circuit as like this. L is open circuited. In the same way, if we consider initial condition for a capacitor, a switch is connected between a voltage source and a capacitor, and when the switch is closed, before switching it acts as open circuit because no voltage source is applied, and after switching it on at t equals 0, when the switch is on, the capacitor acts as a short circuit. Capacitor acts as a short circuit because the property of the capacitor is it opposes sudden change in voltage. As it opposes sudden change in voltage, there is no problem in flowing the current. Okay, so because of that reason, the capacitor is act as a short circuit. The equivalent circuit diagram will be like this. Voltage and the capacitor is short circuited. So by considering initial condition of R and initial condition of inductor L, initial conditions of capacitor C, we are going to derive a transient response of DC series circuit. And also we can easily compare these three things for initial conditions. At t is equal to 0, when it is R, so the resistor will be act as the same thing as resistor. When it is t equal to 0 minus and t equal to 0. And coming to the inductor L, before switching it on, that means just before switching it on, t equal to 0 minus, the inductor will act as a inductor only. But when it is t is equal to 0 and t equal to 0 plus, the inductor will act as a open circuit. Okay. And coming to the capacitor C, at t equals 0 minus, the capacitor will act as only capacitor, and when t equals 0, immediately switching it on, okay, the capacitor will act as a short circuit. If you remember this tabular form, it is very easy to derive the equation for transient response. Okay, so we will go for transient response of RL series circuit. Transient response of RL series circuit. You already know what is the circuit diagram for RL series circuit. A voltage is applied, switch is connected in between, and one resistor and one inductor is connected. This is R and this is L. Okay. So for this, we have to write a KVL, Kirchhoff's voltage law. If we write Kirchhoff's voltage law, then we will get The current we are considering it as I. So if we write KVL, V is equal to IR plus di by dt multiplied with the inductance value L. Okay. So here we have to make it as operated notation. So both sides divide with L. Divide with L both sides. Okay. Then we will get V by L equal to IR by L plus di by dt. So we can rewrite the equation. So d by dt plus R by L of I equal to V by L. Okay, V by L. R by L plus di by dt of I is equal to V by L. The same thing. Okay, this equation is like d plus p of x equal to k. This equation is called a non-homogeneous equation, and this is linear differential equation. So we have to equate both things. If we equate both things, we will get p equal to r by L, x equal to I, and k equal to v by L. And the solution for this non-homogeneous equation is x equal to c e to power of minus pt plus e to power of minus pt integral of k e to the power of pt. Okay. So with this solution, substitute all these things r by L, x equal to I, k equal to v by L in this formula. So now you will get I is equal to c e to the power of minus r by L of t plus e to the power of minus r by L t integral of k means v by L e to power of minus r by L t. Okay. So if you do integral for this one, we will get I equal to c e to power of minus r by L t plus e to power of minus r by L t. So we have done integral. So v by L into e to power of minus r by L, this one plus. Okay. E to power of r by L t divided by r by L. So this L and this L will be gets cancelled. E to power of minus r by L t, e to power of r L t will be gets cancelled. So we will get I is equal to c e to power of minus r by L t plus v by r. Okay, this is not the final equation, and this equation c e to power of minus r by L will be transient response, and v by r will be steady state response. But we have to calculate the arbitrary constant, that is c. For that purpose, we have to consider initial condition. Already we discussed about that. We have to consider initial condition of a circuit. Okay, when t is equal to 0, current I also 0. Okay, so substitute the values here. I equal to c e to power of minus r by L t plus v by r. Substitute this value. I equal to 0. So 0 equal to c e to the power of minus r by L into 0 plus v by r. So that we will get c 0 equal to c plus v by r. So c is equal to minus v by r. Substitute this c value in this I equation. So what we will get? Substitute c value in current equation. So that we will get I is equal to minus V by R into e to power of minus R by LT plus V by R. So we can rewrite the equation I equal to V by R plus minus V by R e to power of minus R by LT. So if we take common of V by R, it is 1 minus 1 minus e to power of minus R by LT. This is the equation for transient response of RL series circuit. And we have to calculate the voltage across a resistor VR. We already know VR equal to IR. Substitute I value here. So V by R of 1 minus e to power of minus R by LT into R, and R will get cancelled. We will get the voltage across resistor VR is V of 1 minus e to the power of minus R by LT. And in the same way, if we calculate the voltage across inductor, VL equal to LdI by dt. Okay, substitute I value in the differential equation. So we'll get L into d by dt of I. I means V by R of 1 minus e to power of minus R by LT. So if we differentiate here, what we will get? L into V by R into differential of 0 0 minus R by L will be multiplied, so minus into minus plus you will get, so R will be multiplied R by L into e to power of minus R by L t. So L will gets cancelled, R will gets cancelled. So the equation for inductor, the voltage across inductor will be VL equal to V e to power of minus R by L t. Okay. So if we draw a graph, the relation between inductive voltage and resistive voltage, if you consider the reference line, then the inductor value will be comes like this VL, and the voltage across resistor will be comes like this. This is VR. This is time. This is voltage, and this is R is in 0. So finally, these are the transient response of RL series circuit. So if you calculate power P across R resistor, so we'll get V into R. So what is the formula of VR? So VR will be V into 1 minus e to the power of minus RL by R by LT into R. So across inductor the power will be VL into VR into I. So VR means V of 1 minus e to the power of minus R by LT into I means V by R of 1 minus e to the power of minus R by LT. And the power across inductor. And the power across inductor PL will be the voltage across inductor and the current. Okay, the voltage across inductor will be V into e to the power of minus R by LT, and the current will be V by R of 1 minus e to the power of minus R by L. Okay. So with this we have calculated the current response through the RL series circuit. That is, finally we getting it as I equal to V by R of 1 minus e to power of minus R by LT, and the voltage across resistor will be V of 1 minus e to power of minus R by LT, and the voltage across inductor will be VL equal to V e to power into e to power of minus R by LT.